Hi everyone, so today we're going to run through scientific notation. Now if you remember from the intro to Indices video, we talked about two stars, Alpha Centauri A and B, and their enormous distance from the Earth, and we touched on the fact that we can use indices to make huge numbers like this a lot easier to look at. So I can rewrite that as 4.13 times 10 to the power of 16. And this is scientific notation, and that's what we're going to look at, how to do that. So what's an example of scientific notation? This is one example of scientific notation. You've got a unit here. You've got some decimal places following it. You've got the number 10, and you've got an index. So a power of 10 here. What are significant figures and decimal places? Well, decimal places, hopefully you know that this has 3 decimal places. But what you may not have known is that it has 4 significant figures. Significant figures are all the non-zero numbers, except if I had a 1 here, I would still have to count all of these as significant figures. So from the first to the last non-zero number, that's how many significant figures you have. Sorry, digit. And the third thing we're going to look at is how to convert to scientific notation. Now, I'm not going to explain all these 3 steps, we're just going to do an example. So write 370,093 in scientific notation to 3 significant figures, so we'll get a chance to use that new knowledge. So we take the digit on the left and write it as a unit in the new number. So let's just write the original number here, and we'll write an equals sign because we're just writing the same number in a different way. So the digit on the left is 3, and that's the unit. Then we've got a decimal point. And now we have to write as many decimal places or significant figures as we need. So we need 3 significant figures. That will be the 3, the 7, and the 0. We don't need to do any rounding because the next number is 0. Or you could say that we rounded down. Now we need to write times, and we need to write 10 to the power of something. Now, that something is determined by how many times we need to multiply by 10 to get to this. So if I had a decimal point here, how many times would I need to multiply by 10 to get it over here where it needs to be, to the right of the unit? That's 1, 2, 3, 4, 5 times. So if I multiply by 10 5 times, that's 10 to the power of 5. So we're done. That's it. It's 3.70 times 10 to the power of 5. And you can see I really shouldn't write equals. I should write approximately equals in this case, because we've had to basically, because it's only 3 significant figures, we've lost that extra information over here. So it's close to the original number. All right, let's do an example of a number that's larger than 10 in scientific notation. So let's write the number, and we'll see later if it has to be equals or approximately equals. We'll just write equals for now. We've got to write the digit to the left. That's our unit of the new number, decimal point. And then how many decimal places do we need? We need 1, 2, 3 decimal places. And now you can see, hopefully, that I haven't had to do any rounding. I haven't lost any information here. So this is actually equal to the original number once I times it by 10 to the power of something. Now the question is, how do I get from this number to the original? I have to multiply by 10 1, 2, 3 times. So That's 10 to the power of 3. Now this next part, 3 significant figures, if I want to change this a little bit, the only difference will be it's going to be approximately equal because I'll lose a bit of information. I'll only have 1, 2, 3 significant figures. And I'll have to round because this last one, I'm losing the 9, so I have to round up or down. Because it's a 9, it's 5 or bigger, then I need to round this up to 8. The 7 goes up to 8, and I still write times 10 to the power of 3. Okay, now we're coming to numbers that are smaller than 10. And just before we start, I want to show you some things that are equal to each other. Because we're going to need to divide by a power of 10. And you need to, for example, this is 10 to the power of 3. And so we're going to need to divide by a power of 10. It might be 10 to the power of 3 or 10 to the power of 4 or 5. Now, this is actually equal to dividing by 10 to the power of 3 is the same as timesing by a fraction, 1 over 10 to the power of 3. And this is the same, if you remember the index laws, this is the same as 10 to the power of negative 3. Remember we had an index law, it went something like this. A to the power of negative m equals 1 over a to the power of m. I don't remember if they were a or m, but this is the index law. Basically, if you've got a negative power, you can write it as a positive power, but you have to flip it and write it underneath a fraction. Well, you can go the other way around as well and say, if I'm timesing by a fraction with a power of 10 on the bottom, that's the same as timesing by that power of 10, but the power is negative. All right, that's a lot of information. Don't worry if you didn't understand that. Because what's really nice is that you can think about this negative power as moving the decimal place to the left. So if I have a positive power, remember, if I times by a positive power, that moves the decimal place to the right. If I times by a negative power, that moves the decimal place to the left. So if you're multiplying by negative 3, you just need to go 3 to the left. So that'll be 0.002. Okay. We can finally get onto it. So, write 0.00765 in scientific notation to 2 decimal places. So, let's write our original number. And is it going to be equal or approximately equal? I wonder if you can work that out. We'll get to that in a second. We've got to write the first number, non-zero number on the left, which is 7. And then we have to write a decimal point. Then we need to write as many decimal places as we need to, which is 2. And now hopefully you can see that I haven't lost any information. It's exactly equal to the original number once I multiply it by 10 to the power of something. Now, how do I get from here, the decimal place from here, to there? Well, it goes 3 places, so that means I'm multiplying by 10 to the power of negative 3. Alright, now if we had to do 2 significant figures, all we have to do is a bit of rounding because 2 significant figures would be 7 and then whatever comes here. And because 5, I've got a 5 here, that means I need to round up, so 7.7 times 10 to the power of negative 3. Okay. You'll probably need to do a bit of practice with this one. And actually, to be honest, a bit of practice with this one as well. So the most important thing for this one is, because you can make mistakes at a few points along the line here, check your answers every time and you'll know exactly when you're going wrong and you'll be able to get some help about that. All right, I'll see you next time.